So let's talk about some concepts related to seed theory. And we will start talking about the most simple examples, considering we have only two separate groups. The Let me write that, right? Raise them. Right, so we can start, right? I think we can. Right, so we can begin. So this DC theory can be explained with the very with the most simple examples. So suppose we have two groups. Let, 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 let's identify them as group A and group B, right? We can identify each group like just a circle, but in a plane, right? So um, for we can write something like this and paste, right? So we can have something like this, right? So in the first one, the group A, and the second one, the group B, right? Okay, so but all of those groups are immersed in something that we call as the universe, right? So the universe is everything that is outside of these groups. So let me draw this shape. We will have something like this, right? Okay. When we are talking about the data or the events that are inside of both groups simultaneously, oh, I don't know why it's drawing up such a star. I don't want that. When we are talking about the events or the data that is happening inside of both groups at the same time, we are using the sign of intersection. So is a intersection B, right? But when we are talking only about the data that is shared or that is not shared, that is present on both groups, regardless if that information of that events are present in two of them simultaneously, we call them the union. So, we can so all of this, 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 all of this. Everything that is marked on dark blue, we call that as the union. The union or A and B, right? And everything that it is outside of one of those elements can be denoted with this symbol, the S. So let's clarify. And we can call the complement as the data or as the events that are located outside of a given group or subgroup of the unit or the intersection of some groups. For example, if we are talking the same case about the, so let me just select this and copy this. Ah, let me select this and copy this. Okay. Let me erase that. Um, oh, that won't work. This will not work. Right, so let's try with something else. This, we can copy that. Oh, what a mess. And we can draw this, but it's fully dropped. Drop. It's okay. We can have this. Okay. So right. If this is the event A and this is the event B, we can call or we can name. So let me have various copies of all of this. So we will be using this later. Okay. Then and then. Okay. So we can talk about the complement of just A as everything that it is located outside of A. This is the complement of A. That is everything that is on the universe S, but not into A. So we can draw that, right? So the complement of A will look something like this. So all of this is a complement of A. Everything in the same universe, denoted with an S, that it is not inside of A, right? So let me draw this. Wanna draw this? Let me draw it. Let me draw. Let me draw. Let me draw it. Let me draw it. Let me draw. Let me draw. Let me draw. Everything but A. But A. This is the complement of A. And the symbol of the complement can be denoted with this. This is the symbol of the complement. This one. And what about the complement of B? Well, that be everything but B. This is everything that is inside of the same universe, but that it is not located inside of it. Right? But we can also talk about the complement of the intersection of both A and B. Intersection. We can talk about the complement of the intersection of both of them that we noted as A intersection B complement. What is this? Well, it's just something like that. And we just use a wider so we can finish earlier. Everything in the same universe that it is not inside of our item, right? And we can talk also about complement of the of the union. Union B complement. What is this? Well, it's just the same principle that I applied on Jules. Right? Right. And is this and this just this?